Welcome everyone. Welcome members and friends to the Southwest Region Hydrographic Society meeting. Today's talk is going to be from James Williams from Unmanned Survey Solutions. So James Williams has been working within the marine survey industry for over 25 years as a hydrographic surveyor, consultant and entrepreneur. He's the founder and managing director of Swathe Services, which incorporates a team of skilled survey professionals who offer product sales, equipment rental, personnel deployment and training. In 2015, James also set up Unmanned Survey Solutions, USS, and embarked on a mission to design, build and operate unmanned surface vessels for a broad spectrum of survey applications. Based in Cornwall in the UK, James has a BSc in underwater studies with ocean science and an MSc in hydrography with distinction, both obtained at Plymouth University. He has been the chairman of the Southwest region of the Hydrographic Society and sits on the Society's Education Committee. And obviously, James, you can now add the interregional liaison to that string as well. And James is committed to pushing the boundaries of surveying and innovation to bring better, safer and environmentally considerate solutions to the survey industry.
As Ian pointed out, I was the previous chairman, and he kindly took over from me when I stepped down. And the reason I stepped down is because I started up another company called Unmanned Survey Solutions. Because a lot of you know me, and this is sort of a regional thing, I thought what I'd do is just give everybody an insight into sort of how this new company came about, how myself and the team that I have got into unmanned surface vessels, and how we've managed to use that to develop our own vehicles and where we sit in the market. So it's not necessarily a sales pitch. It is based on the company and the products, but it's more of a sort of a timeline of how effectively a student from Plymouth University has sort of managed to navigate his career into something I think is actually really exciting, and I wanted to share that with the audience. So as a bit of a background to me, I did a variety of things within the survey industry when I left university, but I ended up starting my own company in 2004 called Swathe Services. And initially, I did that when I left a company called Geoacoustics, and I was sort of an expert, if you can use that word, in the geoswath interferometric system, which is quite a unique bit of kit. Paul, that's just taken over as chairman going forward, knows interferometry very well as well. And it was such a specialist bit of kit, you really needed not only the equipment, obviously, but a specialist operator to be able to use it. So there was quite a niche market there, and that's how the company started. But over the years, things have changed, as every sort of company needs to do within the industries, is grow and change with the times. And now about 70% of what we do at Swathe Services is product sales. So we bring other people's products into the market and we sell them onto survey companies. The other 30% is made up of sort of renting out the demo systems that we have. So we have an equipment rental pool, but it's very small compared to some of the big chaps that are out there. And really, it's just our demo systems that we put out in the market. We still have a personnel deployment, again, very small compared to others, but really highly specialised and quite highly experienced guys as well. And many of them are actually ex-employees that went out into the freelance market. And then the sort of remaining side of that is that we do commercial and bespoke training. So up until 2019, we were running a 5-day hands-on practical multi-beam commercial training course every year. That didn't quite happen last year, but we're looking at running that remotely this year. And we also do seminars and workshops for our suppliers. So these are the companies that we are very fortunate enough to represent. I don't have a huge number. We like to try and concentrate on key blue chip companies. Many people will know, obviously, R2 Sonic as being one of the main multi-beam manufacturers out there. We are the representative for HYPACK in the UK. Carlson make a Merlin mobile laser mapping system. And I've got some images of that coming up of stuff that we've done on unmanned vessels shortly. Sea Hydro Systems are single beams, sonars. Plankterra Systems are quite unique in that they've developed a capability of being able to launch and recover airborne drones onto moving platforms, which is an aspiration we have to work with them with unmanned vessels. Biosonics do scientific echo sounders. Valport, we pretty much all know, and Jim Gardner, who's going to be giving a talk later on this year, as Ian said, is pictured in that picture of where it says consultancy. But the one that's been really good for me is taken on SBG Systems. They're a French-based company that make MEMS-based inertial navigation systems, and not only is the equipment brilliant, it's really well priced, and we actually sell more of those products than all of the other suppliers put together. So that was a really good opportunity that we've taken on. But during the course of running that business over the last 17 years, and with the team of guys that I've got on board, in 2011, we actually secured the rep status for a company called the Ocean Science Group. And at that time, they had something called the Q-boat, which had an ADCP on a yellow remote control boat. I'm talking with Adrian McDonald, that was the main guy. You know, we talked about single beams. It'd be brilliant if we could have a single beam on one of them. And Bourne was the Z boat, and we sold a couple of these when we was the agents for them, of which one of them was to BP. And the interesting thing that really came out of that was that BP wanted to send one of these boats out to a Middle Eastern country, which was a bit sort of dangerous for expats to work in. And they wanted to be able to press a button, set the thing off, run the survey, get the data downloaded through the internet and process it remotely. So the Ocean Science Group didn't offer an autonomy module. So we got them talking with M-Subs, a lot of people certainly about the Mayflower 400 project, which Brett Fanoof is sort of heading up. We took they took their very advanced underwater autonomy program and down-dumbed it to drive this boat around. And we got involved in all of the beta testing to prove it before we then delivered this boat to BP. The reason I kicked off with this is that it is highly unlikely that you will get a company that builds autonomous boats to talk about the very first collision they had. And we was at Millbrook Lake testing this boat. This was the final testing of the Autopilot before we provided a working solution to BP. And we was on a lake which is frequented by a lot of model boat enthusiasts. And this was running its final set lines, and it was doing so well, I decided to put down the transmitter, the remote controller, and pick up my camera. And I took these cracking series of photos before realizing that one of the guys that I'd spoken to, who I'd offered to take photos of his boat for, suddenly appeared in my shot. And I don't know if you can see them out. You see the little guy on the back of this model boat here? Well, he was doing a cracking job at driving straight in front of the boat as it turned for its next line. And hey presto, there was my first major USV collision with, and this time hopefully not a real boat. I had to wade out in my waders and find this thing and bring it back, and it was completely trashed. And unfortunately, I never found the little man that was sitting on the back of that. So he was lost at sea in Millbrook Lake. But that was a classic case of, an autonomy module. Are they really autonomous, or are they just dumb bits of software that are following waypoints? And that's what you'll find with a lot of solutions. But that was I think a £2,500 collision for me, because I had to buy him a new boat. Anyway, we started developing the multi-beam version of the Z boat, and it was actually our Sonic 2020 was the first multi-beam to go on to a Z boat. But it wasn't long into that project that Teledyne bought out Ocean Science, and we actually lost our rep status. So being involved in the early stage with that little boat sort of really piqued my interest, and we started working with another company called Advanced Undersea Vehicles and Systems, and they built something called the Multi-Purpose Unmanned Surface Vessel, and I took my team out to Houston to review it. Their Mark III was pretty awful, to be honest. It really wasn't fit for purpose. And I sat down with the guy that was building it, and we went through a lot of the constructive criticism myself and my team gave, and we came up with the Mark IV, which he called the Switchblade. It was a very interesting vehicle. That the black mast you can see on the screen there actually pivots at the deck of the boat, and the sonar is actually connected underneath, so the whole thing pivots down, which allows you to get the site really quick without any drag, deploy the sonar when you get there, and crack on and do the survey. And it was a really good concept, but unfortunately the build quality wasn't very good. and unfortunately as well, the funding for the company got pulled before they actually made it into a commercial project. I've actually got that boat in my backyard, and it's a pet project I want to do to bring it back to life again, because I was very much a part of the design process on that. Anyway, so Teledyne, or the Z boat didn't work out because we lost the rep status. Then AUVS went bust. So we then went closer to home, and we started working with ASV Global, and we had some really interesting experiences with them. Some of you may recall we bought the CT3 vessel to Plymouth, and we did some work in the Catwater as part of a demo for the Hydrographic Society. Bit of a disaster, didn't quite work as planned. But we also then took that vehicle up and did some work in the River Avon as well. But the one thing that was really interesting was that we actually teamed up with them for Shallow Survey 2015, and even though that the company that we represented, RT Sonic, didn't take part, we was able to actually partner with ASV and be the first sort of joint organisation to collect a hydrographic data set as part of this conference, to sort of talk about and prove that the capability of an unmanned vessel to collect data. We never actually provided the data to the conference, which was a real shame, but I had my hands tied on that. But we used a CCAT-2, which is the picture on the right at the bottom, on a small sort of prototype catamaran, and the Seaworker 6. So the CCAT-2 had a small multi-beam echo sounder, a Sonic 2020, and then we also put a Sonic 2022 on the Seaworker 6, and we worked in a couple of areas, and I've got some data to show. It was a very challenging area to work in. Coastal areas, certainly around the southwest, are difficult. In addition to the standard sort of yachts and motor vessels and divers and jet skiers, there was lots of other users as well as lobster pots. And back then, we're talking 6 years ago, 2015. The camera update wasn't too good, but you can sort of see here on the port side of the boat coming up is a classic lobster pot, and there were hundreds of these buggers all over the place. So, working with an unmanned vessel in coastal regions when you've got things that can snag the props, that proved very, very challenging for that particular data set. But we did it, and that was a really cool thing. We managed to get these boats working as platforms to effectively collect really good, high-quality data. And on this image here, on the left, you can see the line plan, which was a combination of driving the boat manually, as well as running sort of predefined waypoint lines. But on the right-hand image, if you can see the sort of dark red area, that was the area we actually used to try and get in a bit shallow with the CCAT-2 into those very shallow areas out there. And the rest of it was done with the Seaworker 6. And then moving on, we also did work just sort of east of the Great Newstone. Again, that was very effectively. We did it in 2 different orientations to cover the whole area. What I didn't say at the time when we gave the presentation was that we did have a bit of a major failure of the control system of the boat, and we actually finished that survey by towing it behind the support vessel. But we did it. About sort of 95% of it was all done from an unmanned platform being operated remotely, albeit from a support vessel. So that was really exciting. We had a lot of fun doing that. We then worked with them on their Seaworker 5, and we went up to Southampton. The bottom right-hand image is Empress Dock, where they normally hold ocean business, which I understand is now being delayed to October. And we also went up the river and did the Itchen Bridge. And this is where we also put on the Merlin laser again and managed to demonstrate the ability to map above and below the waterline with a high-resolution sonar and a mobile laser scanner. And I've got some tracking images and bits and pieces. In fact, when I started this presentation, I think I had 150 slides. You'll be pleased to know I've got them down to 40. We then moved on to working with the WAM-V, again in Plymouth Sound. This was a really interesting vessel. For those that don't know it, it's got a sort of a hinged mechanism, which I know Seafloor Systems have also developed as well. And it's designed to try and sort of ride over the waves, but keep the platform fairly stable. And it's really, really effective at doing this. It's an incredible bit of kit. The unfortunate downside that we found with this vehicle was that attaching a multi-beam pole was somewhat challenging, and the consortium that we was working with on this particular thing didn't do an overly great job at that pole system. But the other thing was everything, including batteries, control system, sonar, deck unit, INS, everything had to be located on this top level, which was quite a high center of gravity. It was quite heavy. It actually reduced the ability of these springs to work effectively. If it wasn't for that, it'd be an absolutely brilliant boat. Really good, could go fast, go over waves. It went over some amazing waves while we were collecting data. But as a hydrographic platform, it proved somewhat challenging. And it was about this time that I was getting a little bit sort of frustrated, because in our assessment on all of these different vehicles that we were used, that there was a number of different issues. Many of them were complicated to operate. For example, we're used to setting up survey lines in our acquisition package, whether that's sort of Iowa, Quincy, or HYPACK, and running those lines. But on many of these, you had to then export those lines into the Autopilot package, upload them. Hopefully all the geodetics worked and everything was right. Run the lines, and then if for any reason you had to pull off and then restart, back in these early days, you then had to cut the line plan down in the autonomy in the acquisition package, re-export the new line plan from where you finished off, re-import that into the Autopilot and kick off, and that could take like half an hour just to do a restart the survey because of a buoy being in the way. So some of them are a little bit complicated like that and frustrating. Many of them were brilliantly well-designed, hydrodynamically designed boats, but a nightmare to actually fit survey kit to, of which the WAM-V at the end was the classic scenario. Moving on, we did have issues with many of them. I don't think there was one survey we did where we didn't have sort of reliability issues. One of them decided to sort of do a left-hander and try and pile itself into a key wall. As I said, the other one, the Seaworker 6, unfortunately, that had a bit of an issue with its control system when we had to tow that to finish the survey. So that was very frustrating. And ultimately, when they're unreliable, they are higher risk. And if they're higher risk, that's not good. That's not a good route to market. And ultimately, higher risk can also turn into being quite expensive. Expensive if you have an accident, like the $2,500 it cost me with that model yacht, as well as, very expensive to buy as well. And the more advanced the USV is, even today, the more expensive they are. So we had a lot of frustrations. So that was when, rightly or wrongly, I came up with this cracking idea of how hard can it be? And there was born the concept of Unmanned Survey Solutions. And this was why I stepped down from being chairman at the time, because I really wanted to concentrate on seeing if we could take all of that experience, all of that knowledge that we'd gained on other people's boats. And I will just add in here, we wasn't doing this in sort of any secret way. I'd done this to try and find a platform supplier that we could work with to bring unmanned surveying to the forefront of the market. But we were not able to secure a mutually agreeable commercial contract for both parties. And that's partly why it pushed me down. So I thought, well, I'm not going to waste all this experience. I'm not going to waste all this time and energy. We're going to take this and we're going to put it into a design brief. We're going to go to our naval architect. We're going to get him to come up with a concept. We're then going to build it. We're going to build it to the best that we possibly can using the right suppliers and contractors. And then we're going to go out and operate it. And then we're going to feed that back into the whole process and make it even better. Very much like you buy an iPhone. We're on the iPhone 12s now, I think it is, and every year you've got an improvement. And I wanted to be able to feed that back into the process. And ultimately, I want to design, build, and sell these vehicles. But currently, at the moment, there is a much greater demand for the operational side, and to an extent, we have to get these products that we build accepted within the market, and we can only do that by showing how successful they are. So our main aims within USS is to make our products versatile. Modular is very key. We need them to be easy to use for the surveyor. There's a lot of horrible things said about surveyors, but ultimately, if it's easy to use, then people like to use it. So let's make it that. They obviously need to be robust and reliable, and ultimately they need to be at a price point which is cheaper than a manned vessel that can do the same job. So they need to be cost effective. So we kicked off with our prototype boat, the Mark I in 2016, which was a little aluminium boat, just a straightforward remote control using sort of airborne drone technology. That works. That was proof of concept. We then built the Mark II, which is a more stable platform, slightly bigger, and we fitted our first multi-beam to that. But there were a few tweaks that there was a bit too much movement between the two holes through the bridge section. So we beefed up the bridge section, and then we fitted in this payload pod. And this was where the whole modular concept came out, really, was the ability to have one boat with different payload modules that you can fit into the boat. So you could have a single beam payload, an ADCP payload, or a multi-beam payload. So that worked really well and got us going for the inland waterways market, and was good. I think if you go online now to something like geomatching, I think there's over 50 USVs available in the market now. So this bottom end of the market is very flooded. But we've been very successful with our own work, and I haven't actually got any data to show you on this vehicle. I cut all of those presentation slides out. But we've sold this vehicle to people like Trondheim University in Norway. We've had a vehicle go to the Canadian Arctic, so working in the extremes up in the cold. And we also had to do a special cooling pack for a boat that we sold to Tetra Tech that's been working in Saudi Arabia during the hottest months. So, this boat's worked not only in sort of local climates, but in the extremes as well, from cold to the hot. And we've been really proud of what we managed to do. But again, very much a learning curve, even with our own vessels. But the really exciting project, the one that really, really, really gets us excited, and we've had an awful lot of fun developing, is what we call the accession class. Accession stands for the attainment of power. I quite like that. And it was in the early days that a chap called Ben Grid came into my office and offered me some money. There was a European Regional Development Fund that was being run by Marine Eye locally in Cornwall that was supported by all of those people on the bottom. And there was an opportunity to get funding to do a bigger research and development project to build a coastal and offshore boat. So Ben came in 2017 offering me free money, which raised an eyebrow, which wasn't quite the case, but it certainly piqued my interest. And it allowed me to really, feel my aspirations to build a bigger, better, more seaworthy boat. We worked with Ben and we put in our initial application in the October of that year, in 2017. It got accepted, which was brilliant. We then had to put a much larger application, much more detailed application together, describing which technical readiness level we were going to go from and to, which is effectively sort of from a laboratory type scenario up to a complete working system. So it's quite a high jump in TR level. We had to get quotes from all the various components that we wanted to bring into place. And that in itself was very challenging because, we wanted to design a boat. We then wanted to, within the same project, build a boat. And then we wanted to also, build a launch and recovery system. So that was quite easy. You, to a certain extent, you go to the naval architect and say, okay, this is the design spec. This is what you want to build. And they go, yeah, great. Okay, it's going to cost you X. And then you go to the boat builder and say, we want you to build us a boat. And they go, great. What does it look like? And we go, we don't know yet. We haven't had it designed. Right, okay. So he gives you a number that he plucks out the air. Not quite like that. You give him a few ideas, but basically we asked the boat builder to give us a price to design a boat, to build a boat that hadn't been designed. And then we had to go to a launch and recovery specialist to build us a launch and recovery system for a boat that hadn't even been built. So unfortunately, with a lot of these R&D paths, if you are jumping from a very low to a very high TR level, there are a lot of added complications and a lot of unforeseen and foreseen issues that you're going to have with any financing, which made it challenges. But I've always believed, an obstacle, a challenge is just something you see when you take your eyes off your goal. So we persevered on, and we put a whole package together, which we put into for an application. But unfortunately, it took until May of 2018 to finally get that approval. But the great thing was that it was a 70% intervention. So of whatever the package was that we managed to secure, which I'm not going to say at this point, 70% of that was going to be paid, and it was a hefty amount of money, which was brilliant. So that really made the accession come to life. That really made this project achievable. So what was the design? So all of my team and a few other key personnel, we literally went to a pub and had a beer together. Does anybody actually remember what that's like? But we sat down and we said, okay, well, we want to build a vehicle that can, work in a port authority, be fairly small, around 3.5 meters. We want it to be battery powered because we want it to be low CO2 emissions, really good for the environment. We want it to be easy to operate. And then at the other extreme, we wanted to also be able to meet, a bigger market where we could go over the horizon. But really a 3.5 meter vessel out in the big oceans, that's not a very big boat. And even though a 5 meter boat isn't huge, it's certainly going to be a bit better than 3.5 meters. So we suddenly have these different ranges. And when you look at, the fantastic boats that ASV, now L3 develop, as I said earlier on, they've got a Seaworker 4, a Seaworker 5, a Seaworker 6, a Seaworker 7, all these different boats. And if you want different capabilities, you've got to buy a new boat. So, well, why do that? Why don't we just build a small boat, cut it up, and just add hull sections when you need to go out and do bigger and better things? So it's quite an obvious sort of idea when you think about it. So that was a design. Let's make a boat that comes apart and you can add in different size hull sections, of which we chose 75 centimeters and 1.5 meter to give you one boat that you can upgrade for different lengths depending on what applications you want to do. So the sort of thing that you're looking at, as I said, is a DC powered boat for sort of port and near shore operations. That would be a 3.5 meter version that would contain all your control systems, your batteries, your thrusters, and your payload equipment, whether that's scientific gear, a single beam or multi-beam. But if you want to go further, you could add in a 75 centimeter section with additional batteries, or you could possibly put in additional sensors in the other hull section. It's entirely up to you. It's highly configurable like that. So that gives you more flexibility, and then ultimately the 500 version, the 5 meter version, I should say, that really was designed for long endurance operations, because no matter how you cut it, battery technologies come along in leaps and bounds, but you cannot match the performance to liquid fuel. The density is just not there. You cannot get the same capability. So if you want to do any sort of long endurance stuff, people like Exocean that have done a cracking job leading the field with operational stuff going on, they have a small diesel generator on board topping up their batteries, and that's this concept. But the great thing about the 1.5 meter is it's a large section. It's a large single hull volume. We can get a good powered diesel generator to provide all the power we need, and a large fuel tank as well. So that was the concept, which sort of started off in late May. We then spent sort of June and July going through the design brief, fine tuning that, giving that to our naval architect, who then came up with the general arrangements, the GA drawings for that concept that you just saw. There was a few bits and tweaks that we did through that, and then finally, towards the end of November, we finalised that design, and construction began, which was really, really exciting. And I vividly remember the days that I would take out and run up to see how this boat was coming together. Had to have plugs built, which started, I think, in February 19, and then in March, the boat started popping out the molds, and they did a cracking job finishing it. But roll back almost 2 years, when this was all going ahead, I thought, what, I want to launch this at Ocean Business. This is brilliant. This is the perfect show to launch this product. I'm going to do it. I'm going to commit to it. Well, the first boat came out the boat builders 2 days before Ocean Business 2019. I was sweating my pants because I committed to all sorts of stuff. I bought deck space, dockside space to put it on, and I literally drove up 2 days before, grabbed the boat, put it on a trailer, screwed on all the shiny fittings on the top, and a quick make to do antenna mast with some cameras and stuff on, and drove it down to the show and did a product launch. And it was great. It was a really proud day. It was fantastic. But my God, I lost even more hair than I've got now. So that was interesting. But that was when the fun really began, because now we had a boat And now we had to get it working. You know, we'd obviously have designs and plans put in place, which we've been working on in the background to have all these things ready to install into the boat. So then we started fitting all these things, and in June 2019, again, a day I will not forget, was the first day we launched the boat, and it floated. It was like, great, it floated. Not that I had any doubts whatsoever that it wouldn't float, but it's still nice to see something that you've designed and created actually float for the first time. That was really rewarding. So that was a good day, and Jack Gifford there on the right-hand side of the very top left photo was our naval architect, and Russell on the left was my lead engineer at the time. You know, it's thanks to those guys that we managed to get where we were. But one of the things that was also part of the design spec was, you know, it is going to be a small boat. It needs to not only work in conditions you wouldn't normally expect it to work in, but if it does get knocked down in high seas, it needs to be able to self-right, you know, very much like the RNLI boats do. So we fitted it out with sandbags and to represent the weight that would be in a final product, and we turned it upside down, and it came back up. So that was really rewarding as well. You know, we did a really good flip test, and I've got, you know, we did a really good marketing video on not only the introduction to the boat, which can be found on our website, but also on the flip test that we did, and that was a cracking day as well. So it floated. It turns back up when it gets knocked down. So that was good. So we then towed it out to sea to see how she just floated around. It was actually a particularly good day when we was working in the harbour, and I'm like, come on, let's go out, let's tow it out and see how it looks. And it's a great opportunity to get some cracking photos as well for marketing. So that worked really well in June as well. So then we brought it back in. It's okay, well, this thing now needs to start working. We need to get it driving itself. So for the next couple of months, we started pulling in all of the motors and the batteries and the power management system and getting the RC control working with it. And we did our first underway trial in August. That was fun. And then the weather deteriorated a bit, and we was out in the harbour in September, and it was blowing a hoolie. There was, you know, kite surfers and all sorts of stuff going past. And I'm like, come on, let's see how she performs. And we took her out into the sort of entrance channel to Hull Harbour. And again, there's another video on our website that really shows the stability of that vessel working in some very horrid seas. So that was great. Next stage was to start the other thing, obviously, about being robust and sort of having contingencies was the boat at the moment, when we first started, had differential thrust between the two motors to be able to turn the boat. And that worked quite effective. But if you lose one thruster, you're then a bit stuffed to be able to get home. So having the ability to turn the motors, the azimuth thrusting capability was very, very important. So we then built that into the design and tested that, and that worked brilliantly. So we know how to work in boat. The Autopilot was working. We've done some tests with that. So now we had to install the multi-beam kit. So that started in December 2019. So that was good fun. And then we got to a point where we can really start going out and playing with the boat and seeing how she behaves. Now, our offices are based in Hull, in Cornwall, which is on this right-hand map. We're just here next to a beautiful 3-mile golden beach. So it's a cracking place to be and work from. We're right on the harbour. It's got the nastiest of sandbars at the entrance, absolutely horrible. So you really have to be careful of when you're going in and out, especially if you ever come back in on an ebbing tide with a big swell coming in. It can get really nasty over that bar. However, that being said, and all put into the RANs and statements and risk assessments and everything else, we've done a fair amount of work in St Ives Bay, testing the systems, testing the boat, and she's performed really, really well. And it was really, 2019 was getting the boat built, put together, getting all the systems working and installed, and then in 2020 was when we, really started to start putting the boat through its paces, and this was the prototype boat. Excuse me. We also done a fair amount of testing in the Fowl River on the south coast of Cornwall, and this was on a very wet day where we was not only calibrating the sonar but also testing the Class B AIS system we had installed. Sort of beginning to get into moderate sea states, the vessel sort of speeding along there if the video's working at about 8 knots. So yeah, really pleased with, if you look at a lot of product shots that you see of unmanned vessels, they're all in these perfectly calm, lovely conditions. So it was really good to sort of show how the boat behaves a bit in rougher weather. So that was a good day. And then we had our first commercial job, which we attempted with this vehicle. This was actually a chap that I met at one of the CHP meetings, and it was Conway Council. They didn't have much money. They wanted some work done, and I wanted to get some exposure of the boat and its capabilities. So we put on a Sonic 2024, again with a mobile laser scanner, and we went to do some scour assessment around Conway Bridge in northwest Wales. This was a horrid location. Unfortunately, I think it was March when we did it. It was one of the highest spring tides of the year, as it is around then. And the tidal regime meant that we only had about a 3-hour window at high tide to be able to get into the shallow areas. But the tides that was ripping through the under the bridge and out the other side were horrific. And one of those smaller yachts, actually, I saw it do a 360 on a single point mooring with one of the back eddies that were formed. So, totally the wrong place to use an unmanned vessel. You had moored boats on trots, you had moored boats on swing moorings, and where the boats weren't moored, when the water was really rushing out, a lot of the boys disappeared under the surface. They're hard enough to see when you're on a manned boat, let alone looking through a camera on an unmanned boat. So very challenging, but we did it. We got a really good data set. We'd planned 3 days to do it. We'd actually did it over 2 high waters over 2 days to get everything that we needed. So we were really pleased with the results. And to be honest, I can't take the credit for it. It's my team, because the only way we did this was by being really slick, knowing our boat, knowing our control systems, knowing how to approach the job. And it was actually not the boat was brilliant, not that we knew the area. It was we knew how to operate our boat. We knew its limitations, how we had to deal with it, and the team did an absolutely fantastic job. I was just taking lots of pictures and trying not to put my oar in too much, as one does. But yeah, they did a cracking job. The mobile laser scanner we used from Carlson, it's not the highest resolution laser scanner, but it's very good at being able to effectively visualize things above the waterline with the multi-beam below the waterline. So that was great. Really enjoyed that, and the customer was very pleased with the data that we provided them with, especially over on the other side of the bank where they've not had any previous survey data collected as well. So that was good. We then did some work with Ultraboom, which is a company that's literally in the same set of buildings of us. Andy McClay that runs it with Gabriel Walton. There's experience there from the BB Hydromap guys. They've done a lot of pipeline surveys, but we joined forces with them and they bid on a job for 2 gas pipelines in Northern Ireland, one which crossed Larne and the other one across Belfast waters. Now, again, very challenging. You can see the GoPro here on the back of the boat, just showing how much it's bouncing around. We had to deal with, as you can see in the other photo, windsurfers crossing the Belfast waters. Lots of cargo ships and ferries, and lots of buoys as well. So very, very challenging. I think one of the things we really learned here is that you can see that the cameras are all on the forward mast. And for those of you of the younger generation that still play games on the Xbox or driving games, there is a significant difference between driving a car game, which is sort of looking out the window where you can see the bonnet of the car, to when you're just looking out the windscreen and you've got nothing to reference it to. And one of the things that we found quite difficult on this particular survey was that because we had no boat in any of those forward camera video frames, it was difficult to sort of judge where the boat was going or how it was interacting with any of the particular objects that may be in its path. But the thing that was really good that we gained from this, I'm going to pause that one and play this one, because this isn't time tagged with PPS or anything like that, but it's pretty close. And this shows the screen recording of the data acquisition of the multi-beam data while the boat's operating in these conditions. And to me, this really demonstrates that even though this is only the 3.5 meter boat working in sort of moderate seas, you've still got really good quality multi-beam data coming in real time. And that's a key thing, that a lot of these small boats that try and go out in rough weather, they find it very challenging. But we've been really careful with how we designed everything. And the things I haven't really picked up on about the design of this boat is she's got what they call a reverse bow design. So when you're going over a wave, it sort of punches through the top of the wave instead of bouncing over it. So it reduces the pitch motion fore aft. And as demonstrated here, we also have these 4 stabilization fins on her, and that reduces the roll motion, whether that's side on or whether that's stern on. And that allows us to obviously operate in rougher weather for longer periods, which is absolutely imperative for obviously doing sort of coastal and offshore survey work. So there you can see how much the support boat is working. And unfortunately, we had to use a support boat yet again because we wasn't able to cross the Belfast Channel without a support boat in attendance. So that was somewhat frustrating, but again, allowed for classic photography and marketing material. But again, the boat's really, compared to how much the support boat was rolling, she's really relatively stable for her size. So really, really good performance. We're really pleased with how she worked out. And then another job we did for a company called MSDS Marine, marine archaeologists. We did some work over the HMS Hazardous down in Southampton waters off the east coast. And again, pretty good start to the day, but soon deteriorated, and we still managed to get, really, really good clean data. Unfortunately, the only thing that you sometimes get with certain systems, even in shallow water, is that if they're not pitch stabilized, you get the bunching of pings, which when you then offer in a point cloud format, you sort of get this bunching where you see the sort of white lines. That's where you've got more pings bunched together. So that's not motion, that's just purely the distribution of pings along track. But yeah, really good experiences, and the boat really performed very well. And then the very last thing that we did, which I was quite proud of, is that we worked with the Port of London to help bring some unmanned hydrographic expertise to the UCL hydrography course that they run. So we took the boat up there, we got it launched, and then we had the various students signing in and running the surveys, obviously all in conjunction with the PLA staff. So that was really, really good fun, and a great way to finish all of the operations that we did last year. Excuse me. They weren't all without near misses. They weren't all without an incident in some manner or form, but a great learning curve. But that was a prototype boat. That was a boat that we designed the best as we could, that was worked in a way that we wanted to work, and then we put it through its tests. We then took all of that experience and then we fed that back to our engineers, and we now have 4 engineers at USS that are all building these boats, and we did a full sort of, the things that we're now bringing in are a complete sort of full drivetrain torque and vibration analysis to make sure that that the steering mechanism that we're using and that the components that we're using do not break unless under extreme circumstances. So for example here, the the name's gone completely out of my head. The device that we use to steer the boat, embarrassing, that will only fail now if we lose one blade on one prop and we go from hard port to hard starboard. It's only at that point it gets anywhere near the limits of its operation. So we've done really, really good engineering into making sure that the systems going into the next boat, which we're currently building, has got full engineering backing it up. We've also actually now finally got rid of that very quickly built antenna mast that we did for Ocean Business back in 2019. And I thought very closely about how we want an antenna mast to work, where we want to put the components. We're now putting all of the 4 cameras in the rear mast, so that gives us perspective on the front of the boat looking forward. We've got a 360 camera. We've got your various Wi-Fi and 3G modem antennas, the AOS antenna as well on the back. We've got SATCOM's capability. We've got a small vector-based position and heading system specifically for the boat control system, as well as locations for your INS GPS antennas. And that mast folds down into places. It pivots here, and the antennas at the back pivot down, so you can fold the thing down for transit. So that's all currently being built. We've also completely redone the whole power management and battery management side. We now have a LCD display on the boat, so you can open up the rear hatch, vertical hatch that's on the back, go in, it will tell you what battery you've got left, what your expected endurance is based on different speeds, on the current voltage that's in there. You've got the ability to charge the system. Before, on our prototype boat, it wasn't quite a case of putting crocodile clips on batteries inside, but it wasn't far off that, and it was quite a complicated turn on off procedure, which got my surveyors scratching their heads at times following sheets of paper that weren't laminated and all runny. But we've now got a full system where the battery charging's in place, and you literally, it's like a Tesla charger. You just plug in the charging cable and it charges. And the whole wiring side, the whole system now, the power distribution, the ability to switch has really gone from a very sort of rough and ready agricultural prototype like this, bits of wood, what units do we need, what DC to DC converters, where do we need the fuses, where do we want the switching, how do we want all that to work, to something that is, industrial level grade with industrial components that do not fail. And we have manual switches, we have remote switches, so we can turn off power to the payload bay, or we can just turn off power to the sonar that's on board. We've got all of that you can either do from the LCD display on board, or you can do that remotely through remote access to the onboard systems. So great stuff. We've got a 4.25 meter boat which we're building at the moment, and that'll be ready at the end of April, early May. We're still working on additional autopilot and motor interfaces. We currently use Torpedo motors, and they're a bit of a pain to communicate with, and some of the technical information that goes with it isn't quite matching what comes up the pipe from the motor. So we've completely redone all of that. We're also sort of building in automatic fallback, so if we're using Wi-Fi and that falls over, we can kick over to 4G, and then if that 4G falls over, we can go over to SATCOMs, and that's auto-selecting, which is really helpful. And one of the things that happened on the PLA job, the very last job we did, we finished at the end of the day, we plugged in the charger, we plugged it into the power outlet on the pontoon, went and had a beer, and I think it was about 5 minutes after we'd left, it tripped the power outage on the pontoon. So where we thought the thing was charging overnight, it wasn't. So we've integrated an auxiliary battery and 4G alert system. So if it stops charging, or if there's other key systems that stop working, it pings your mobile phone to let you know. And the other thing we're working on as well is we've been working with CMAX that developed the Vigo underway profiling winch, and we're working to develop a much better recovery and capture system for the sound velocity profiler. We're using the Swift. But if you do a static control, the line goes down vertically. If you're doing an underway cast, the line goes out horizontally. And you've still got to capture the sound velocity sensor when it comes back in, because you haven't got anybody there to grab it. So that's proved a little bit challenging as well, which we're working on. And then the other things that are coming forward, on Monday this week, we got confirmation of Marine I2 to actually build our launch and recovery system to work with motherships. So we've now got funding towards that, which is brilliant. It's only 65% as against 70, but that's going to allow us to have the capability to work with a mothership as a force multiplier, which is great. We're also going to be developing that generator capability on the 1.5 meter pod so that we can go over the horizon on longer endurance jobs. The one thing that we do not have expertise in is autopilot. We have developed a way to follow waypoints, which a lot of boats can already do, but to be able to avoid collisions or objects is not built into our autopilot. I don't think there's actually, from what we've managed to research, we're in the market for a third-party autopilot from somebody else, and we're looking at people like Dynautics and others, Maritime Robotics, but none of them really, in my opinion, have got a proven, ready, affordable collision avoidance capability using things like AIS radar or visual methods. Your typical sort of LiDAR that you have on a car for collecting something is great on a flat surface, but as soon as you go up in the air, it sees the sky, and then as soon as you come down and you see the next wave, it will interpolate it as a brick wall and put the brakes on. So we are going to be upgrading our autopilot using a third-party capability. But the way we've built the system is that we can take a variety of autopilots. So they're the current developments for this year. But by June, we should have both the original prototype boat redone as well as the new 4.25 meter boat. So there's a few unique selling points, but it's been a real challenge to get where we are. It's been a huge learning curve, and the one thing I would like to say was that we started 6 years ago. Well, no, in 2011 we started with the Z boat. I took a good 5 years assessing the market, what was going on, before we started developing our own. But we're not funded by the Irish government. We're not like Ocean Alpha, that's pretty much owned entirely by the Chinese government. We're not ASV Global, that are now owned by L3, that have got huge amounts of military sort of money behind them. All of this has been developed from a little bit of money we got from European Union through Marine, and it's all been self-funded from the profits made out of the success of Space Services. So we haven't got there quick. We haven't rushed. I think we've been very methodical. I think the product that we've come up with this time is absolutely awesome. It's very unique in the market. I'm not aware of anybody else that has anything quite like this. And the processes that we've gone through to prove the boat and test it, 2021 is going to be a fantastic year, and we're already talking with a variety of companies about getting this vehicle on survey contracts, and that is still on the same business structure as Sway. So Sway Services supports survey companies. It either sells them kit or rents them kit or personnel. USS, we are here to support survey companies that want to get into working with uncrewed surface vessels, and I think that's an interesting to think on, concept to think on, to finish on. We talked about ASVs, autonomous surface vessels, in the very early days. I talked about unmanned survey solutions, but really the rest of the market is all now going over uncrewed, because almost every one of them needs a man in the loop. And that's the key thing. They're not autonomous, they're not AI, they're not clever. Maybe some of the really advanced, expensive military ones possibly are, but that's not at a level price point that you can put on these vehicles for us as hydrographic surveyors. So that's me. I've rabbited on. I don't know how long for. Quite a while. So I hope that was interesting. We are based down in Howe in the southwest, and if anybody wants to pop in, COVID regulations applying, they are more than welcome to come and see what we're doing and what we're playing. So thank you for the opportunity.
Thank you, James. An excellent talk, actually, really, and actually really honest as well. It was good to see the sort of crashes and the test cycle, from the start. So, and actually quite a lot of good advice in there as well for anyone that's considering building their own unmanned survey vessel. So thank you for that. Can I open the floor up for questions then now? It's probably easier to manage this by hand raising, if possible. I'm struggling actually to see everybody all on one screen, so we'll try our best. So anybody there?
I'll ask a question.
Go on then, Rick, as you started.
James, that was brilliant. Thank you very much indeed. I really, really enjoyed that. But right at the end, you said you needed a crew member, which is what I was going to ask all along. What do you actually see? Are you looking at a camera, or is it a TV screen, or how are you driving this thing?
Sure. I have been particularly cagey about some of the key components of the system for obviously commercial reasons. It's highly competitive at the moment out in the market. We have 4 static cameras looking fore, aft, port and starboard, and a 360 camera which we can turn and has infrared capability. And you have we have an AIS Class B, which updates not on a hugely regular basis. And to be honest, the AIS is only really good for when you're going over the horizon. For real-time updates, you need probably a higher class AIS. It depending on the application and where you're working, it can be challenging. You know, I'm aware of a lot of companies getting escorts out of the rivers and the harbours with a support boat until they're taken control of, and then go off and do their survey work. Working around the southwest coast with the huge number of lobster pots, it's just an absolute nightmare, because trying to pick them out on a boat that's bobbing around through a camera that doesn't have you know, you can get fairly good fast update rates, but the issue that everybody suffers from is, you know, we're all used to doing surveys on a boat where we're looking at the multi-beam data coming in, we're looking at our coverage plot, we can see these high resolution cameras streaming in HD. But as soon as you start having to remote in and see all this data, you know, the bandwidth becomes really important. And we don't stream all the data off the boat. We do what pretty much everybody else does, is we remote terminal into the onboard computer. So like we're zooming in now and sharing a screen, you know, whether it's TeamViewer or another package, we are remotely terminaling into the onboard systems. So that's where we've got the cameras playing, where we've got the AIS display going, where we've got the standard sort of HiPAC or Quincy plan view showing the coverage. But there is latency, and it is challenging to see things like lobster pots in front of you. So I'm very much a believer of picking the right tool for the right job. I certainly wouldn't take an unmanned vessel back to Conway ever again, not in my life, because that was totally the wrong application for an unmanned vessel.
Yeah, it does seem as if it's going to be something that's economically viable in very specific areas, because if you're going to have to take escort vessels and a team of people monitoring it all the time, then I get to the stage where I start to say, well, why don't you have a small boat with a couple of guys in it?
You're absolutely right. So you know, in that respect, if you've only got a support vessel just escorting you out the harbour because the harbour master's not happy with an uncrewed surface vessel in these waters, you know, you've maybe got half a day or a day's rental of a manned boat, and then it goes off to do its offshore wind farm survey for however many days and comes back. That is a cost-effective way of doing it. We did a large job for a survey contractor in Bristol's inner harbour, the floating harbour they've got there. Now we had to have a chase boat the whole time because it was such a complex area. We couldn't really do that remotely. But where that did work is that we had to get in between the boats to do the quay wall inspection behind the pontoons. You could not have done that with a manned boat because they're too big. So that's where a small boat comes in good and actually works very well in with a support boat, because there's no other way of doing it. But it's the age-old question, isn't it? You know, if you've got a support boat you've got to have, and you've got to pay for both, well, you might as well just put the survey kit on the support boat. Yeah, I mean that's the thing. So, as I said, it's about picking the right tool for the right job, and not every application is geared for autonomous work. Until we get to a stage where, you know, your autopilot can detect a dive flag or a lobster pot or a swimmer or a dog, which we have lots of swimming up and down Howe Harbour, which drives me entirely crazy when we're trying not to obviously have any incidents in our home port. But the other thing as well is, you know, bandwidth. So doing it over Wi-Fi is great. Doing it over 4G works really well. But as soon as you go to SATCOMs, if you want any decent sort of connection, it suddenly becomes hugely expensive, and you have a time delay. So, you know, you couldn't do a survey using SATCOMs in, say, a very busy harbour. It just would not work. So until, you know, Elon Musk gets all these low orbit satellites up and there's infrastructure over the horizon that you can tap into for good bandwidths, then I think everybody's going to challenge in this industry. But it'll come. It'll come.
Yeah. Thank you very much.
Do you mind if I ask a question, James? How's it going?
Yeah, good to see you, Aaron.
Yeah, so Obviously, we're using the same technology as you in an academic setting, and we like every USV operator, we come up against the comms question. So as you said, if you're not using SATCOMs, you're wrestling with 4G, with Wi-Fi, but also we use the demo tactical communications IP mesh radios. I noticed you had on one of your slides, it said radio link. I just wondered where you'd gone to with that, and what your experiences were with getting as long a range as you can using not the cell phone system.
There are systems out there, as I'm sure you're aware of, and I know Kongsberg do a cracking system as well, that can give you really good long Wi-Fi, and mesh is really good where you can just bounce off various stations. We haven't gone down that route yet. The whole concept of this boat really was born out of working as a force multiplier with a mothership. So you're never really going to be that far from your base station. That's why the launch and recovery vehicle is so important to get that developed this year, because without that, we're not really meeting the actual goal that we started with. The thing I struggle with comms is that there are good systems that are out there, but they are pricey as hell.
Yeah.
Some of them you're talking like 15 grand at each end. That's £30,000 before you start putting in some other bits and pieces and antennas. And what, simple things that I didn't realize when I first started is the different types of antennas.
Yeah.
So you can get a very tall antenna that'll do a very narrow sort of radio connection, which will give you far range, which is great. Or you can get a short dumpy antenna that'll give you a broad spectrum but at short range. So you think, well, okay, we want the long antennas. We want to be able to go long range. But as soon as the boat starts bumping up and down and moving around, they disconnect because they're too narrow a beam. So you need the short dumpy antennas with the broad angle to be able to make the connection, but then you can't go very far. So if there's one thing I've learned from building boats is everything's a compromise. It's just finding the right combination of compromises to make you have an effective tool to get the job done. And that's been the biggest learning curve I've found through going through this process. And I think for the package that we've put together, I'm pretty pleased with our solution.
Cool, thanks.
Next, I'm just going from the top. David Parker, do you want to ask a question?
Yeah, thanks, Ian. Just check I'm not muted. Thanks, James. That was a really good talk, really comprehensive. And as Ian said, really honest about all the steps. I think we definitely need to have another conversation at some point about how you manage to keep the cash flow rolling for that period of time. But I think that's a conversation for the pub, probably not for this format. I'm very impressed with all of it, and it's looking really good. So
the answer to that, you marry an accountant, which is what I did, and that was the best business decision I ever made.
Right. Okay. Good answer. So you've already said it to some extent, but what I've seen in some of the ASV work that we've been involved with, either very close in or at a bit of a distance, just receiving the end result, is some of these platforms, the 3-4 meter sort of size platforms, similar length overall to yours. They, to be frank, in any sea state, they seem to produce quite noisy data sets, and they're very prone to that. And then what seems to happen is a load of kind of further engineering is required to try and improve that issue. So I just wondered if you could comment on how you're ensuring that, because of the shallow depth of the sensor and all that, that you're not, getting loads of bubble wash down and managing to obtain what looked like quite clean data.
Yes. So the secret there to us is twofold. First of all, on the 3.5 meter boat, we did a lot of testing with putting the sonar at different heights below the hull. So if you have it too flush in rough conditions, the bubbles from the bow go over the face of the sonar, and it kills the data. So you lower the sonar down. If you lower it too far down, then you get a lot of drag, which reduces your endurance, because DC boats are great for the environment, but they have limitations on their endurance. So you don't want drag where possible. So you can then put a cowling, a bubble over the sonar head. The other thing that we've also looked at is that by going to the 4.25 meter section and put in the sensor package in the extra hull section puts it further away from the bow, which gives the bubbles more time to dissipate before it actually gets anywhere near the head. So the first bit of testing we'll be doing in sort of late April will be at what height we need to put that sonar based on the fact that it's further away from the bow mount of the vessel. So, but we're expecting that to be less pronounced off the bottom. I mean, we're only talking about 10 to 15 centimeters below the hull, so it's not a huge amount, but everything counts on a battery powered boat on getting it right. But
okay,
as I said, the reverse bow for pitching and the stabilization fins we've got, it's really been good at reducing the motion. And I've been particularly, and I'm not just saying that from a sales point of view, you know, I've been particularly pleased with the performance that we've seen with our own operations.
great. Okay. One other point to add, just to show my age and to show what a small hydrographic world we live in. Those two gas pipelines across Belfast and Larne Loch, I put those in, or rather I did the survey support for those jobs when they were actually laid. And I think it was 1997, one of the first jobs I did. So did all the land survey sort of guidance, because we had laser guidance across the lochs telling everyone where to dig, and then going out with the boat, you know, doing all the dredging surveys, and then the sort of post-build survey as well. So, and then I left it in 97 and forgot all about it until now. So thank you.
Well, you must have done a really good
Glad
job.
it's still there.
As far as I'm aware, there wasn't any evidence of the pipeline actually popping out from the seabed, but that was a really interesting project because it wasn't my guys running the job. We provided a USV operator, and I went along to take some photos and make sure nothing went terribly wrong. But it was actually Ultrabeam that provided, as it was a freelance surveyor, to do the survey work that had never operated with our boat. So they used Quincy, which interfaced fine with our Autopilot, and they run the whole survey. The only sort of slight issues we had is, like, you know, on a manned boat with lots of power, you'd like, okay, well, we actually want to start over here because it's convenient, but we're like, well, no, actually, we want to start at the closest point because we want to maximize our battery endurance. We don't want to do it the easiest way necessarily for the survey. We need to think about how we approach this from a finite power requirement. Sometimes the best way of doing a survey isn't necessarily the most efficient way of using the power on board, and that's, I think, that's what's really come out of the operational side, is the some of the additional considerations you need to think about before you actually approach the survey. But what was really good was that, you know, this guy had come on board, never used our vehicle, and he worked with our USV operator. They had great comms and took control, and he ran the boat and did the survey. And then the customer processed the data. And that's where we really fit in, is being able to provide this service of providing the boat. And we can stick the customer's kit on the extra section if they want. You know, it doesn't have to be our kit. So.
Okay, thank you. Really good talk.
Next, Steve Keedwell.
Hey, James, thanks for the great talk this evening. It's nice to see you capsizing a boat deliberately as opposed to accidentally.
That was Jim Powell, that weren't me.
Oh, really? That's not what the story he told me. Anyway, two questions for you. And I have to say, I really like the honest view you've given. It's great to see the journey that you've taken here with the uncrewed surface vessels. First question is around basically competency of your, shall we say, your remote pilot. For your uncrewed surface vessel, what you're sort of looking for there, right? Is it RYA level qualifications? And then the second question, my experience has been so far, when you begin to, shall we say, use as a force multiplier with multiple uncrewed surface vessels, you end up in a very in a situation where you have a huge amount of data coming in, which actually, you know, on a normal sort of crewed vessel operation, you can monitor, you can then, you know, sort of turn data around very quickly. But with uncrewed surface vessels, you've talked about the challenges of comms, not being able to transfer the data. I'm just wondering, you know, in your future developments, how you might address some of those issues so that we can really sort of reduce down the volume of data during operation, so you give better sort of quality assurance in real time, and perhaps even, you know, an artificially interpreted map.
Good points, Steve. Thanks for them, those challenging questions. I can't remember what the first one was now.
Around competency.
Competency, yes. So,
yeah.
sorry, yes. RWA level 2 with a commercial ticket attached to it is the minimum that we use to drive our boats around. Some of the freelancers that we use have got offshore yacht masters as well, but it's typically the sort of RWA level with the commercial endorsements attached, because that's typically the waters that we're operating in. You know, we're not really needing a master mariner to go over the horizon with the current boats where we are at the moment. As we develop that capability and go on to that, then that is certainly a consideration that we will be looking at. In terms of comms and multiple boats working as force multiplier, yes, I think the whole operational side is going to change. You know, we started off before COVID by people being on board manned vessels. I know there's been a lot of work by a lot of companies, including Fugro and people like Deep, that have gone over to operating remotely by remote accessing into those onboard systems. But as I said earlier on, you know, just being able to do real-time quality control over the horizon through a SATCOMS link, you can't look at the same number of displays that's up there. So how we quality control hydrographic survey data with low bandwidth capability requires a game-changing shift in the method that we do, and some level of autonomy, I think, built into the data acquisition packages that can tell us whether it's good or bad, or whether there's a hole that we need to go back to. So I think how we operate going forward is going to change dramatically for the surveyor. But in terms of data management, truth be told, you know, we're not as advanced as some of the other companies are in looking at cloud-based solutions for being able to get data up into the wider audience. At the moment, I'm more concerned in making a good, stable, reliable platform that can go out and collect data. I'll take that one cash flow step and one challenge at a time, and it will come. I'd love to see more than one of my boats on the same job. That'd be absolutely brilliant, and that'd be a great thing that I'll come to you and ask how to solve.
All right, thanks, James. Thanks for answering my questions. Appreciate it, mate. And I'll be down to see you when COVID restrictions lift soon, I hope.
You're always welcome, Steve.
Thanks.
Next then, Ross Taylor, would you like to ask a question?
Yes, yeah, thanks for that. Thanks, James. Yeah, it was interesting to hear your story there. It's good. I did have a question about future development, but I think you just answered it with Steve's question. But, have you got any plans about extending the capability of the instruments on the vessel, you know, sub-bottom profiler, something like that?
Yes, I do. We have a really exciting project that we're working with a partner on, which alas I can't talk about yet. But if things go the way I hope they will, we may be able to demonstrate that in October at Ocean Business on the Water. So I think one of the key things to any of these vehicles, certainly what I think the Armada fleet are going to be demonstrating very effectively, is the ability to do full geophysical suite of kit. Because there's no point just having a multi-beam on a boat when you need to do side scan, Maggie, and sub-bottom. I think towing a gradiometer is going to be quite challenging behind any sort of unmanned vessel. And even though, you know, something like an R2 sonic sonar can give you really good high-resolution bathymetry and backscatter in the form of TruePix, sub-bottom profilers can be fitted into the boat. That's great. So that sort of ticks off the bathy side scan and sub. But it's the magnetometer data for the full geophysical suite that I think is going to be challenging, and I'm very reluctant at towing anything behind an unmanned boat. I just think it's highly risky, and if it's not less risk, if it's not cheaper, then you shouldn't be doing it. So my answer to your question is yes, we do have something in the pipeline, which I think is going to be very unique to our vessel and to the world. And if it comes off, hopefully we'll be demonstrating that in October.
Thanks for that. Yeah, look forward to seeing that in October.
Are there any more questions from anyone at all? I think you've wowed everyone, James. I think they're all speechless, actually.
No worries.
last call for any more questions.
We only lost 2 people, so I'm doing pretty good.
Yeah, it's not too bad, is it?